Welcome back to the tutorial on capturing mental representations through crowdsourced scoring. Again, please refer to the corresponding paper and the OSF repository. So in this fifth and final lesson, I'm going to tell you, now that you have your drawings, how do you actually quantify these drawings? And the big picture I want you to take away from this is that any judgment you can make on a drawing, you can also ask tons of people to do online instead. And so why would we crowdsource scoring of these drawings? Well, first, it is faster and more efficient than in-lab scorers. As I mentioned before, there's often over 10,000 people available on Amazon Mechanical Turk at any given moment who can then help to score your drawings. This also helps to eliminate the biases of the experimenter. If you have in-lab scorers or your self-scoring drawings, you may be looking for specific features and you may be biased to see those in certain conditions over others. Using crowdsourcing can also capture levels of confidence by using an aggregated score across individuals. So if you want to see how good is a given drawing, rather than asking one person, you could ask 20 people and take their average score as a level of confidence for how well a drawing was created. You are also able to do a number of drawings that are infeasible for a single person. So if you have images on the order of thousands of images, or even if you have hundreds of images, but you want hundreds of judgments for each image, then you can easily do this online, collect enough people to get over 100,000 judgments on different images. This is harder to do in person. And so in this lesson, I'm going to give you some ideas of types of information you can crowdsource scoring for, but really the options are endless. So you can ask for ratings on image-based metrics. One that we commonly use is something I call image matching or a drawing judgment, where we put the drawing next to a photograph and we just ask online scorers, is this a drawing of this image? And they can then respond on a Likert scale. And this gives us a sense of what is this a drawing of and how diagnostic is this drawing of the image? Is it really specific to this image, or how well does it rate if we compare it to other bedroom images? You can also ask people to rate a drawing for many other features like aesthetics ratings, how high quality the drawings are, drawing ability of the person who made the drawing. You can also get ratings on things like viewing perspective. Is it a top-down view or a frontal view of the image? You can also ask for short response descriptions of the drawings. You can also look at object-based metrics, so more fine-grained metrics within an individual image. For example, in many of our tasks, we ask participants to tell us which objects are in the drawing. So we iteratively show each object highlighted in the photograph and ask whether that object highlighted in red is in that drawing or not. And we do this for every single object, every single drawing. So this is a level of detail that would be hard to do in lab. We also get measures of where each object is located. So we'll show online scores an object highlighted in red in the photograph, and then ask them to move and resize an ellipse over the drawing to show us where and how big that object is. We also often ask for false memories or false objects. So we ask participants to list what objects exist in the drawing that do not exist in the original photograph. And these are just a few ideas. Here are some other ideas for object-based metrics. You can also ask people to rate the aesthetics, drawing quality, or viewing angle of individual objects. You can also ask online scorers to describe the details of an individual object. So for example, you could ask them to guess what material is this object made out of, or how common is this object? How shiny is this object? How expensive do you think this object would be? You can also show online scorers a video of the mouse movements that were made for creating a drawing and ask them to rate something about the development of the drawing strokes. So for example, you can ask online scorers to say, what was the first object that was drawn? What was the object that was drawn for the least amount of time, etc. Okay, so how do we code these online drawing scoring experiments? Well, I highly recommend you use something like Amazon Mechanical Turk, because AMT is really well suited for brief tasks you want to crowdsource out to many, many people. I recommend that you code brief hits. This is Amazon Mechanical's Turk's term that they use to refer to tasks. HIT stands for Human Intelligence Task. And you can usually use create these online scoring experiments as a survey, mainly in HTML. You can sometimes add more complex functionality with JavaScript, but usually it doesn't reach the level of complexity as the drawing experiment itself when individuals are actually creating drawings. And what's great about AMT is that you can easily do high volume and really rapid tasks where maybe you pay participants a few cents to do a 1 second long task. AMT is also great because it allows participants to do as many hits as they would like. Many other platforms are designed for more traditional psychology experiments when you're participating in a set number of many trials over a longer period of time. But for these sorts of scoring tasks, we just want high volumes. It's okay if someone wants to do 2 trials and someone else wants to do 1,000 trials, as long as they're enjoying doing the task. So let me go through some general conventions on creating these online scoring tasks. It's good to generally keep your tasks short, even as fast as just a few seconds long, like 1 to 5 seconds. It's also good to sometimes include catch questions because recently there's been questions in the field about data quality on Amazon Mechanical Turk. There are some bots that participate in tasks. There's sometimes AMT farms. And so it's just good to make sure that people performing these rapid tasks are doing them in good faith. And so what we'll often do is include some common sense English questions, like what do you call a baby cat, a kitten, just to make sure they're paying attention, performing the task, and that they're a native English speaker and that they're not a bot. It often doesn't make sense to include a catch question on every single trial when every trial only lasts a few seconds. So you can include them randomly. So maybe only on 30% of your trials or 20% of your trials. Or what we often do is tell participants to only answer the catch questions when it's their first time doing this type of trial. Make sure your task is written in very simple, easy to understand language, and also make your task as efficient as possible. Rather than prioritizing things like aesthetic quality, you want to really limit the scrolling. You want to make it, if possible, so that your entire experiment fits on a single screen. And you want to make it easy to parse because you want it to make it easy for the scores to just go through the experiment rapidly. It's also good to not reveal the source of your drawings. You want your scoring to be blinded. So we avoid telling participants what these drawings are. We don't tell them, oh, you will see some drawings of memories or drawings made by individuals with aphantasia. We often don't say where the drawings are from. If you decide that you do not want to use Amazon Mechanical Turk for your scoring tasks, an alternate method is to do something like combine Prolific to recruit participants and pay participants and have them directed to a Qualtrics survey in which they're making these scoring responses. But using this sort of combined approach is much less efficient because it involves more clicks and more times for the participant. I also might discourage you from doing a fully self-coded version because it is harder to recruit the large number of participants that you would need if you're hosting this on your own server. And so to go into more specifics on how to code a drawing scoring experiment, there's a few things that are useful to learn when interacting with Amazon Mechanical Turk. And that's how to actually change the trials and how to save information from your trials. So essentially, in terms of the inputs to AMT experiments, anything written with this specific syntax will be dynamically changed across trials. So this syntax of $, curly braces, and then the name of your variable, if you have that in your code on an AMT experiment, it will change, it will swap out what's in there for each online participant. Then in terms of output, AMT saves values from all input tags that have a name field. You might remember in one of our previous lessons that we talked about the HTML input tag that's often used for questionnaire items. We also use hidden tags to save things like the drawing data. Well, that's what AMT knows to save. If it sees an input tag and it has a name field, it will save that in the CSV file that it outputs to the experimenter. Input tags do not have to have a name field, so make sure you do include one, because if you have an input tag that does not have a name field, AMT will not save it. Finally, make sure that you have a submit button. Make sure you test out your code and make sure that you do have a working submit button. You can insert that into your own code, or AMT will insert a submit button if you do not have your own. So let me just show you an example online scoring experiment. So these are all in the repository under the online drawing scoring section. And I'm just going to show you the example that is a drawing judgment task. So this is the one where you see an image, you see a drawing, and you say how well that drawing matches the image. And so just off the bat, you'll see that this is pretty quick, and it is mostly coded in HTML. Again, because we see these carets, these tags everywhere. You will see here that we do have an input here, and it has this name. So this is asking the main question of how well does the drawing match the image. And you'll see it will be saved under this name of match response. So when you get the CSV file from Mechanical Turk, you'll have a column called match response. And in that column will be all the responses across all the trials from all the online scorers. This input is of the type radio, so it's a radio button. Let me just show you what this looks like on the page. So this is a radio button here where you can choose one of multiple options. And then later we also have a catch question. This is the one place in which we use JavaScript. What this JavaScript is doing is just generating a random number from 1 to 5. And then we ask participants to report what was that number. And this is to make sure they're not a bot, because a bot would not be able to perform this task of seeing the number and reporting what it is. And because this JavaScript is randomly choosing a number each time, if I reload this page, you will see the random number changes. Okay, so up here, you will see we have 2 broken images. And this is actually where we insert the drawing and the image being compared to the drawing. And the reason it's broken is because we've done what I described earlier to allow you to input information into Mechanical Turk. So here are the 2 tags that show the images, this IMG tag. Usually under the SRC, the source, you would have the URL to the image. So it would be something like http://blah:/blah:/blah.jpg. But instead we have here this $ curly braces image, $ curly braces drawing. And what this is telling Mechanical Turk is that I want these 2 variables to change for the multiple trials of my experiment. So what you would do is you would copy all of this code into a new project on Amazon Mechanical Turk. Then when you're publishing the experiment, it will prompt you to upload a CSV file. And that's where you specify the different trials and the different inputs that would go into these 2 variables. So let me show you an example of what one of those CSV files looks like. So that is. Okay, so this is an example of what the CSV file would look like. This is a very simple one because it's only a single trial. We have, again, you might remember we had image and drawing as our 2 variables. And here we have image and drawing separated by a comma. And then here's one trial with an image path and a drawing path. But if you wanted to have many, many different trials, you would have many, many different rows. And it wouldn't just be kitchen, it would be other images like, let's say, living room, bathroom, etc. One thing here is that Mechanical Turk is expecting a CSV file, a comma separated value file. So here you really do need to have commas separating each of your variables of interest. You cannot use another character like the vertical pipe I was using in other places. Yeah. And so how do I generate this input? You can manually create the CSV file like I was just doing and just showing you. But one thing is that you need to create your CSV file so that includes all possible trial variables. One great thing about this is that AMT will distribute these randomly. So let's say I have my CSV file. Let's say it's all in alphabetical order. Luckily, participants will not see them in alphabetical order. They will participate in the trials randomly. But one thing to keep in mind is that when you have large numbers of stimuli, say you have hundreds of drawings, it can be helpful to programmatically generate the CSV file rather than create it manually. You can also programmatically generate it in a smart way so that it's dependent on prior experiments. So you might remember I showed you an example experiment where you have to indicate whether a drawing in a photograph was in the, whether an object in the photograph was in the drawing. And then there's also an experiment type where you have to say where that object was. Well, it doesn't make sense to have online scorers tell you where an object is if it's not even in the drawing. They can't even perform that task. So in our code base here, we have some examples of this dependent CSV generation, where it sees what objects did participants determine existed in the drawing, and then from that, it creates the list of trials for judging where that object is. So let me just show you an example script that can generate these CSV files. And so I've written these in MATLAB, but really they can be written in any sort of programming language. And again, we're going to revisit that drawing judgment example. So this is a MATLAB script, generate drawing judgment CSV, that's available on our code base. And this is actually a pretty straightforward short script. It basically asks for what are the URLs that you're interested in, what are the folders it should refer to that contain the images that you want to put in the CSV file, and then it iterates through the drawings in the folders and outputs it to a CSV file using the fprintf function. And now, now that we have the input, now we've generated the CSV file that we upload onto Amazon Mechanical Turk. Then we have participants undergo our experiment, or specifically, we're having people scoring these drawings in a multitude of ways. And then finally, they're done and the data is saved on Amazon Mechanical Turk. Well, how do I see this output? So the data is saved as a CSV file from Amazon Mechanical Turk. In an earlier lesson, I showed you briefly what that looks like, but let me just show you again. So once the task is done, you can go into Manage. You will then see your list of tasks and you can go to Review Results. Here's some example data from an experiment we had run previously when we're looking at the results. And you can see it's all as a table here. In this example here, we can see what we inputted. So these inputs are what we uploaded on that CSV file. In this case, we were showing participants 6 images. So this is showing what were the 6 images this given participant saw. We see some of their demographic information, and then we see the base 64 representation for one of their drawings. Yep. And then each one of these rows here represents a different participant or a different online worker who participated in one of these trials. And then you can just click download CSV here to download that CSV file. One thing is, once you get these results in, make sure to reject or approve your hits. Usually we tend to be fairly generous. We tend to approve most hits unless if it's very clear that someone did not perform the task at all or that they cheated, then we will reject them. But often a rejection can cause a huge hit to a worker's reputation and might prevent them from participating in other tasks. So please be cautious when you reject workers online. So I have included scripts with the code base that can save the CSV data into a MATLAB structure. So I will show you an example of one that does this for the drawing judgment task. So here in that folder, I have an analyze drawing judgment.m file. And essentially what this does is it iterates through the CSV file that comes out from Amazon Mechanical Turk, and it saves it into a structure. And it does some basic interpretation. So for example, depending on what radio button they press, it saves it as a different number for the response. And then later on, it does a little bit of averaging, saves it onto a structure, and then saves that as a MATLAB output. That being said, you can use these examples to parse any Amazon Mechanical Turk output that you get. But really, this sort of script can be done in any programming language that you're familiar with. And this is true for both the code that generates a CSV file that you input into your experiment and the code that interprets a CSV file that's outputted from your experiment. I just do it all in MATLAB. One reason for this is that we do heavily use this tool called Label Me. This is an online tool that lets you label where the outlines are for individual objects in an image and have it all saved as coordinates in an XML file. Label Me is currently MATLAB specific, and that's why most of our code is written in MATLAB. And you will see in the code base references to Label Me, and we include links also. So other than having individuals score these drawings, how else can you quantify these drawings? Well, I encourage you to check out the wiki as well as the paper, but there are many computational ways in which you can score these drawings. Some examples are the natural image statistical toolbox we've provided from our lab. Aditya Khosla also has this great resource available for extracting computer vision features for images, such as popular features like GIST, SIFT, and HOG, which we talk about in the paper. You can also calculate visual saliency measures for the images. And also you can use deep learning to try and classify different aspects of your drawings. And so now that you have these ratings, you know where objects are, what objects are there. Maybe you have a visual saliency or deep learning measure for a drawing. What do you do with these ratings? Well, there's many different comparisons you can do. You can compare a drawing to the image that it was made from. For example, you can look at questions of like, what percentage of objects were drawn from that image? You can also compare conditions within or across participants. So for example, how do memory versus perception drawings compare? What percentage of drawings done from perception were drawn during memory? And in fact, as I mentioned in the very first lesson, I encourage you to consider comparing drawings to drawings rather than drawings to images, because drawings to images are very different formats. You can also look at the same condition between participants groups. So how do drawings done by those with aphantasia versus those with typical imagery compare? And one thing I really get into in the paper is this idea of comparing drawings as object vectors, rather than comparing pixel level measures or a measure that exists for just an entire image, so one aesthetic rating. One powerful method is you can represent a drawing or an image as a vector of its objects. So for example, if there are 30 objects in a given living room image, you can then get measures for those 30 objects in each of the drawings. So for example, you can get a measure of what percentage of participants drew that image from memory, or what is the average aesthetic rating for that object. And then you have 30 different ratings for each of the drawings that you can then correlate across participant groups, across conditions, or in this way, you can also even compare a drawing to an image. And so the main takeaway I want you to get from this lesson is that rather than you scoring the images yourself and the drawings yourself, you can get the crowd to score these drawings for you. And at first, while drawing might seem like a very subjective, very qualitative output that is hard to score and is influenced by things like drawing ability, well, if you're able to crowdsource it, then suddenly it becomes a really objective and very rich measure. Yeah, and so that's the end of the tutorial series. I thank you for your attention. And again, if you have any questions or comments, feel free to visit our website or send me a tweet at Wilma Bainbridge or email me at wilma@uchicago.edu. Thanks, and see you later sometime.